Hi, this is Miss Gunter, and today's lesson is going to look at multiple representations of a function. This is a must-do lesson. The aim is how can we analyze functions, and the objective is I can compare the average rate of change for different functions. As we learned before, a function can be represented in different ways, including as a table, a graph, or an equation. In this lesson, we're going to calculate and compare the average rate of change of different functions represented in different forms. So let's look at an example. So here we're going to order the functions f of x, g of x, and h of x from least to greatest by calculating the average rate of change over the interval 2 is less than or equal to x is less than or equal to 4, and we can write that as 2, 4. And from least to greatest, that basically means from smallest to largest. Okay, so let's look at the first function, which is in the form of a graph. So the interval is 2, 4. And of course, these are both x values, so we can think of 2 as x1 and 4 as x2. Now, to find the corresponding y values from a graph, we look at the x coordinate, then we move it down to the graph to see what the corresponding y value is. And of course, f of x is the same thing as y. Okay, so when x1 is 2, if we move down to the graph and across to the y value, we'll see that the corresponding y value is negative 12. So one coordinate is 2, negative 12. And then when x is 4, if we do the same thing, we will see that, let's change in the color. We go to 4 on the x-axis, and then we move across to the y-axis, and we'll see that the corresponding y value is negative 2. Now, in terms of calculating the average rate of change, the average rate of change formula is y2 minus y1 divided by x2 minus x1. And of course, we can label these as x1 and x2 and y1 and y2. So plugging those values into the formula, we have negative 2 minus negative 12, and that's divided by x2, which is 4, take away 2, and when we simplify that, we get negative 2 minus negative 12, which is the same thing as negative 2 plus 12, so that's 10, divided by 4, take away 2 is 2, and when we simplify that, we get 5. So the average rate of change for this graph over the interval 2, 4 is 5. Okay, here we have a table, and it's the same interval, which is 2 and 4. Okay, so we have x and g of x, so that can be considered as x. G of x is the same thing as y. When we have a table, what we have to do is look at the x value on the table and find the corresponding y values. So these are x1 and x2. So when x1 is 2, the value of y1 is 40. And when x2 is 4, the value of y2 is 22. And of course, the formula for average rate of change is y2 minus y1 divided by x2 minus x1. Substituting these values into the formula, we have 22 minus 40, and that's divided by x2, which is 4, minus x1, which is 2, When we simplify that, we get negative 18 divided by 2, and that gives us negative 9. So the average rate of change over this interval is negative 9. Okay, here we have an equation, same interval, 2 and 4. When we have an equation, what we have to do is to substitute each x value into the equation to find the corresponding y value. So we can rewrite this as, instead of h of x, that's the same thing as y. So we can say y1 will be equal to negative, and wherever we see x, we replace x with the value of x1. So it's going to be x1. It's going to be x1 squared so it's going to be x1 is 2, so let's erase that. So it's going to be 2 squared plus 7 times the value of x1 is 2 plus 24. So it's going to be y1 equals negative 2 squared is 4 plus 7 times 2 is 14 plus 24. When we put that into the calculator and simplify it, we have y1 equals 34. So we have a coordinate pair. That's 2 and 34. Okay, to find the value of y2, we have to do a similar thing. We're going to take the same equation and replace x2 with the value of x2. Replace x with the value of x2. So we're going to have y2 equals negative, and the value of x2 is 4. That's going to be squared plus 7 times 4 plus 24. That's going to be y2 equals negative 4 squared is 16 plus 7 times 4 is 28 plus 24. Simplifying that, we get y2 equals 36. So the other coordinate pair is 4, 36. And the formula for average rate of change is y2 minus y1 divided by x2 minus x1. So that's going to be equal to, we're going to call this x1, y1, and x2, y2. So y2 is going to be 36. Take away y1, which is 34. And that's divided by x2, which is 4. Take away 2. And simplifying that, we get 2 divided by 2, which is 1. So the average rate of change over this interval for the equation is 1. So the question really asked us to find the average rate of change over those intervals for the 3 different forms of a function, and then rank them from smallest to largest. So the average rate of change for the graph was 5, for the table it was negative 9, and for the equation it was 1. Putting these in order from smallest to largest, that would be negative 9, then 1, then 5. And of course the negative 9 corresponds to g of x, the 1 corresponds to h of x, and the 5 corresponds to f of x. So our final answer, placing these average rate of change in order from smallest to largest, is g of x, h of x, and f of x. Okay, so that's it.